Hello again, learners. How are you doing? It's me, Mourad Sultan Ezouidi, the Tunisian mathematical teacher, with you always to train yourself for solving the third degree polynomial equation. Okay, and I wish that everything is okay with you. Okay, so don't forget to prepare your papers. Okay, what else? Scientific calculators, and prepare for yourself a desk and a chair and sit. Okay, this is the first step. Sit and watch your lecture so that you can work through new methods. Okay. So as we told before, we'll try to let you learn new methods. Okay, for solving nth polynomial equation. We did all, let's say, some examples that deals with fifth degree polynomial equation, fourth degree polynomial equation, and seventh degree polynomial equation. Also, it remains 8, 9, and so on. It's very easy. Just focus on the method and focus on the discriminant formula of Mourad Sultan Ezouidi, so that you can work all work out all the roots of your nth degree polynomial equation. So today, learners will try to solve third degree polynomial equation. It's very easy, in fact. Just apply what's given, and you'll find out your extra roots. Okay. So start. This is our example. Okay. This is our example, learners. I'm going now share. I will share the screen with you, learners. So the example is that it's a third degree polynomial equation simply because learners x is raised to the power 3. Okay, if it is 4 means fourth degree polynomial equation. It is 6, it will be sixth degree polynomial equation. If it is 7 means you are going to work with seventh degree polynomial equation, and it's not easy to solve this kind of polynomial, learners. Okay, it depends new methods, new strategies, new theories like Mr. Mourad Sultan had done. Okay, now let's work together and go step by step. This is, learners, our third degree polynomial equation that had been written as x cubed minus L0 for the q x squared plus L1 for the q x minus L2 for the q equals 0. If you are going to equate your first third degree polynomial equation to this, you will note that L0 for the q equal 11, and L1 for the q equal 96, and L2 for the q equal 361.625. Okay, so you will work with this coefficient of your original third degree polynomial equation to find your new third degree polynomial equation that will give you the x roots of your target. Okay, so if we focus on this, it seems like to be a third degree polynomial equation, and we want to find, let's say, the roots of this polynomial equation. We should learn the value of sk minus 1, of order r to relative to LR of all the Q. Okay, where, let's say, R, learners, belongs to the set of numbers minus 1, 0, 1, and 2. This is the strategy. Okay, if you are going to work with any nth polynomial equation or with any linear with any nth degree linear equation, you should, learners, find sk minus 1 of the q. Okay, because this one will help you solving and finding out all the exact roots. Means here we'll never use the method of approximation method, or the method of Newton, or the method of Calvin. Okay, because these three methods that I already mentioned is or are using let's say, approximation. They will give you not exact value. They will give you, let's say, a root that is near to the root that you are searching out, but it will never be equal to 0. Okay, but we as Mourad Sultan Ezouidi, we will give you a method. How can you find exact roots? We find exact roots, then you are going to ignore the previous methods that will give us error estimation. Okay? Because an equation, if you are going to talk about an equation, it's an equation that has to be equal to zero, not has to be equal to 0.002 or to equal zero point 0.3. It has to be equal to zero. There is no other solution for that. Okay, if you tell that it is an equation and I'm going to solve it, means that the right hand side should be equal zero and the left hand side should be written in terms of x. Okay, and the roots, when you replace the roots, has to be equal to zero. Okay, so learners, I'm going to focus on my method. I will use the discriminant formula of me. Okay, this is my discriminant formula that will give me the new coefficient of the new third degree polynomial equation, and through that I will use them to solve or to find first the x roots, and after that I'm going to replace the x roots on on a formula that I will write after explaining this to find the roots of your original polynomial equation. Now, learners, for k equals 0, we'll write as minus 1 over the r is equal to 1. Okay? And we continue. We want to find S1, S0 learners. If you would like to find S0, you should set k equal 1 in my discriminant formula learners so that you will obtain S0 of O the R equal n minus n times L0 of O the Q. L0 of O the Q is different. 0 means this one is equal to 0. Therefore, the value of L0 of O the R is always equal 0 for any nth degree polynomial equation or for any nth linear equation, because there is a relationship between two things: linear equation to the power n and polynomial equation to the power n. There is a big or strong relationship between these two things. Okay. Now we told that as I'm working with the third degree polynomial equation, so the x roots, the sum of the x roots has from the equation. Okay, we continue. I'm going to calculate S0 learners. S0, we told that it's given as a formula to be negative combination 3 choose 1 times 11 plus 3 times 11 equal learners negative 33 plus 33 equals 0. We by convention S0 is 0. Okay, meaning because the sum of x roots has to be equal to 0. Like you are working with the second degree polynomial equation, when you told the root of delta minus root of delta has to be equal to 0. Okay, now we continue. I'm looking, or I'm trying to find S1 learners. My learners, S1, if you would like to find the value of S1, you should put k equal to the discriminant into the discriminant formula of me, which is written as subscript k minus 1 of order r equal the sum from 0 to k combination n minus r, choose k minus r n raised to the power r between parentheses negative L0 of O the Q raised to the power k minus r times LR minus Q. Okay, look here, learners, the n here denotes what exactly? Denotes the highest power of your polynomial equation that you would like to solve it. Okay, means n here is 3 because the highest power of my polynomial equation is 3. Okay, now we continue. We told after developing this formula, this discriminant formula of me, I will obtain exactly as 1 over the r equal negative combination 1 choose 1 combination n choose 2 times L0 for the q raised to the power 2 plus n squared times L1 of the q. This one is very important, learners. Okay, if you would like to work with the second degree polynomial equation, you will obtain this also. Okay, but you should change the negative sign. Okay, now learners, I'm going to focus on the method. I have my coefficient of my original third degree polynomial equation, and then I'm going to replace in the discriminant formula while putting k equal to means s1, okay, I will replace the coefficient. Therefore, I will try to use a calculator at the same time, learn this. Therefore, a 3 that I multiply by minus 1 gives negative 3 times 11 square plus 3 square times 96. I will use calculator if it is possible. I told that negative 3 times 11 square is 1 to 1. Okay. Then plus 27, plus 9 times 96 times 96 or 96, whatsoever we pronounce it. So this is 90 plus 6. Okay. So this one is equal to what, learners? Equal 501. I will change this one by 501. Okay. This is the S1, the value of S1. Okay. Meaning the second coefficient of your new third degree polynomial equation, you obtain it as a value of 501. Clear? Clear, Mr. Mourad. We continue. Now, learners, for k equal 3, okay, I will set k equal 3 in my discriminant formula here as k minus 1 over the r equal the sum from 0 to k combination n minus r, choose k minus r, n raised to the power r, between parentheses, negative L0 for the q raised to the power k minus r times LR minus 1 of the q. Therefore, learners, you as you are an advanced learner, okay, you can develop and expand this, and you will retain to the last one, or you will come to the last one, the green one. You tell that S2 really is equal to 2 combination and choose 3, and 0 for the q raised to the power 3 minus combination and minus 2, choose 1, and square times L0 for the q raised to the power 1 times L1 for the q plus n cubed L2. Okay, this is the S2. Okay, the last value for new third degree polynomial equation. Okay, but if you are going to extend your third degree polynomial equation to the fourth degree or fifth degree or sixth degree or n degree polynomial equation, you should continue. Okay, means some other polynomial equation can be solved, but if you are going to extend and you are going to work with, you will get your exact roots without no approximation method. Here, Mr. Mourad Sultan Ezouidi, after his let's say after working more than 14 years researching in this field, he just found some theories, or he just discovered or invented some methods, some theories with their proofs. Okay, and he published this on Amazon and on the European universities. Okay, those who are looking for or interested in these books, they can immediately go to Amazon or go to the edition, okay, European University, and they can buy from them. Okay, or just send me an email. I will send you a copy. Okay, we continue. I want, let's say, you to learn something new. In fact, okay, because these methods, no one had seen them before. Okay, but with me, with Mourad Sultan Ezouidi, I will give you this method and these strategies to help you understand first the bridge of the block of bridges. The polynomial equation can be can how to say it, can settle in. Okay, means inside the block of bridges there are so many nth degree polynomial equation, and these nth degree polynomial equation are new, not the nth polynomial equation that I already studied before. Okay, and you didn't find their exact roots. Here with me, Mr. Mourad Sultan Ezouidi, you will not only learn from me, but but also you will be able to solve whatsoever the power of the polynomial equation that I work with. But you should be very smart and very intelligent. Okay, We continue. We told that we found S1 and S2. Therefore, learners, this is the original polynomial that we worked with, isn't it? X cubed minus 11x squared plus 96x minus 361.625 equals 0. As it is an equation, whatsoever the root that we're going to substitute here in your third degree polynomial equation has to be equal to the value that is written on the right hand side, which is equal 0, not which is equal 0.0020 or something like that. No, has to be equal to 0, learners. That's why here we'll use methods and new strategies and new theorems and new, let's say, discovery. We are going to planify new discovery where you can really find your exact value, your exact roots. Okay, there are two different between roots and x roots. Roots is the root, the exact root of your original polynomial equation, and x root is also an exact root, but it's the root of your new third degree polynomial equation or your new nth degree polynomial equation. Okay, okay. I wish that you got the point, at least, learners. Okay. So we continue, learners. We told that we obtain a new third degree polynomial equation that has three x roots. It's called x1, x2, and x3. x1, x2, x3. If you are going to take the sum, you will get 0. Therefore, learners, now I'm going to write the formula. Okay, so beta subsect 1 means the root of my original polynomial equation has to be equal to that. L0 for the R plus a fraction, negative L0 for the R plus 3 times root of negative S1 over the R plus root of S1 squared minus 4 S3. Okay, all divided by 2. You see this discriminant? It's derived from the fourth degree polynomial equation, means I extend my polynomial equation, okay, and I obtain S2 equals 0, but S1 and S3 are different to 0. So I use this one to solve this, okay. Therefore, I will just continue, learners. You see, L0 multiplied by 4 will give you 4L0 for the Q. Then minus L0 for the R will give you 3L0 for the R plus 3 times the root of negative S1 for the R plus the root of S1 square minus 4S3 all divided by 2. All divided by 4 because this is 4, you see, this is 4 divided by 3. Why? Simply because I'm working with a third degree polynomial equation. Okay, Mr. Mourad. Okay. Therefore, learners, you can see this is 3 and this is 3 on the numerators. And this is 3 on the denominator. It's called the common factor. So I can simplify them to be L0 plus root of negative S1 for the R plus root of S1 for the R squared minus 4SR3. Okay, all divided by 2, of course, inside the root. All divided by 4. We continue learning here. So I'm going to focus on this. Beta 1 equal 11, okay, minus 810. From where we got 810, some learners can ask me, Mourad, please, can you explain from where you got 810, okay? And from where you got, okay, 1,106,704. It is randomly, Mr. Mourad? No, it's not randomly. With time, we will learn. With time, we will see how it was. Okay, divided by 2. So this one, I'm going to simplify, learners. The values that are inside the root, it will be 11 plus. I'm going to simplify or divide 810 divided by 2 will give me negative 405. Okay, and this one, learners, you see this one? You see, 1 million, okay, 1,106,704. 1 million, okay, 106, okay, 704. I will divide them by 4. Okay, I divide this by 4, learners. Okay, so this one equal what? Equal 27,6,676. 27. Of course, there is no 0 here. I'll just repeat again. So we told 27 sorry, not 27. We told 1,106,704 divided by 4 only. Okay, so it will be 276,676. Okay, why I divide them by 4? In order to simplify this two, you see, 810 divided by 2 will give me exactly negative 405. And this root, I will, let's say, sort out the 4. It will be 2 here. Divide by 2, it will give me exactly this. Then this one, if you are going to find the root of this, okay, or you can divide it by 526, learners, you will get 526 as it is, okay? So it is 526. So therefore, I can write 11 plus root of negative 405 plus 526 square. The root of a square is the value that is inside the root, means 11, okay, plus, you can see this one, I will add negative 405 minus 405. So this one has to be really equal to 121. So root of 121 is 11. Therefore, 11 plus 11 is 22. Divided by 4 gives me 5.5. This is a root, learners. Okay? Is a root. Okay? Is a root of what, learners? Look here. Is a root of the original polynomial. This one is a root of this. I will do this for you and try to understand. Okay? I'll put it here in front of under the equation, this one. Okay, I'll go up if it is possible. And up, yes. And down. Yes. Okay, where is calculator? We told this one, I will put it here. We told learners beta is 5.5. It's a real number here. I'm going to replace or to change or to substitute for x equal 5.5 in my original third degree polynomial equation. I will write 5.5, okay, raised to the power 3, because this is raised to the power 3, minus, Mr. Mourad, minus 11, yes, minus 11 times 5.5 square. Okay, plus learners 96 times only 5.5. This one is equal to 361.625. I mean, the left hand side is equal to this. I'm going to make minus 361 point 625. This one is equal to 0. Means this is 0, not 0.001. If you are going to use the Cardan method or the Newton method or the approximation method, you will get some roots which is near, in fact, but is not the exact root. Okay, we continue. And the other roots learners are complex numbers, okay, which are equal beta 2 equal 11 minus root of negative 931 divided by 4, which is equal to 11 minus root of 931 I divided by 4. This is the second root. The third root is that 11 plus root of 931 I over 4. Now, I'm going to explain from where we got 11 plus 931 raised to the power half times I over 4. Okay. Now, learners, I'm going to extend. Let's say we gave this example, learners, because I'm looking for finding the contrary example for the method of Cardan. Why? Because the method of Cardan, learners, works for some third degree polynomial equation, but for other polynomial equation is not true. Okay, and I have at least more than 4 examples for this. If we offer one example, means the method is not true. Okay, I mean the method of Cardan method for solving third degree polynomial equation is not correct. Okay, this is what I mean exactly. Those who are working with the Cardan method, this method is not correct, is not logic, because we offered more than four examples, that really tells is not true. Okay, and I will give these examples for you. Okay, it works for some, yes, but it doesn't work. But it does not work correctly for other third degree polynomial equation. Clear this step, this point. I think I wish that you got the point. Okay, we continue. We am going to extend learners my third degree polynomial equation to the fourth one. Okay, degree, Mr. Murad, don't forget. Okay, so here the new polynomial equation is written as that x4 minus 11x cubed plus 96x squared minus 361.625x. Okay, I extend my third degree polynomial equation to the fourth degree polynomial equation. Okay, so therefore the S1, S2, S3 are derived from my discriminant formula of me. Now I just apply the formula. So I just calculated learners. I'm calculating S1. I obtain S1 equal 810. Okay, I'll just make like that. Please, it's very important, learners, for you. These methods, you didn't see it before, sure. Okay, but with me, it's you can tell that yeah, you are now at least this formula or these methods or these strategies are on your hands. Okay, waiting for what? Waiting for practicing and applying. Okay, and waiting for you to be spread out. Okay, not to reach the method and keep it where you are now. Let this formula, this discriminant formula, and these methods be spread out as quick as you can, because this is for humanity, not for me or for you. Okay, ask yourself why you are training yourself, and what you are learning exactly is to help people, to let others who didn't solve uh, polynomial equation, or they don't have any idea about it. Okay, and some professors or some researchers thought that it's absurd to it's absurdity, or it's absurd, or it's impossible to solve n degree polynomial equation. No, it's not true. With me, we solve everything. Okay, and with you, with these methods, we'll solve so many things. Well, this is let's say dealing with third degree polynomial equation. We get, let's say, fourth, fifth degree polynomial equation. You can visit my channel, learners, and you can learn if you are interested. If you are not interested, what can we do for you? We will advise you more and more. Okay, may one child of you, when you get married and you will, let's say, you will get kids or sons or daughters, they will ask you, dad or mom, what to do with I faced the problem with the nth degree from equation. What can you do for me? Okay, you will tell him, I will forget. I remember the mathematical teacher Mourad Sultan Ezouidi, who discovered this and who is publishing and making live stream for learners, for anybody to learn and to understand the method and to practice the method and to go deeply into the block of bridges. Okay, that really helps us to solve nth degree, to solve not only nth degree polynomial equation, but also, you see, but also nth linear equation. Nth linear equation is something very important and very believable. I love this kind of subject. Okay, it's really abnormal, something very very important. I wish that you ask me one day for solving nth degree linear equation, and you see the difference, and you will see how we are so smart and how we are very intelligent to relate between nth degree polynomial equation and between the nth degree linear equation. Very very important, and we have formula for this. Okay, so if you want, we'll see which kind of formula I'm going to show you. Just okay, just a moment, learners. I will see if it is possible. Okay, okay, Mr. Murad, Mr. Murad. Now comes here, Mr. Murad. This one, yes. Okay, yes. Okay. just a moment. I'll show you where. This is Edition University, where I published my book, learners. We didn't finish the example, please. I don't go so far. Okay, continue. Okay, continue, please. Alhamdulillah. Okay, these learners, my, you see, this is, yes, my, okay, my researches. Okay, how many projects did I work, learners? I work with 10 researches, 10 books I wrote, and I published 10 books. 5 I got the okay, and the other they told me no, the version is not clear, something like that. I wrote 5 in English and 5 books in French. They accept only the French books, and they didn't accept the English books, which kind of desertion, okay, and discrimination. Sorry, okay, means that the French people or the French as a country does not like the British as a country. Why not to publish books in English? Okay, but I did this. Okay, now learners, I'm going to show you something. Methods. Okay, this is 4 to the power 4. More than 300 examples. Okay, solved by me, of course. This is new theorems and methods for solving polynomial to the power n. Okay. This is to the power 18. You see, to the power 18, a book that was being published, learners. Okay, okay, published Mourad Sultan Ezouidi. This is also, learners, okay, if it is possible, open. If it is possible, learners, see, polynomial to the power 12. This is book is written in French. I went to write it in English, but I wrote it, but they didn't accept this version. Okay, so this is the 12th degree polynomial equation. I solved it. It contains how many pages? More. This is for 8, yes, polynomial to the power 8, okay, and so on, okay. So I will now solve. I will go to this one, learners, okay. What is the download? Linear equation. This is my book, okay. I'm going to read, okay, this is my book. It's written in French. I don't like to speak French, okay, because I dislike this language, okay. As I studied everything in English, I studied whatsoever all the subject in French in Tunisia, okay. But you see, English is very important, but French to the hell. Okay, we continue. So here, learners, I will show you this. You see the method here. I'll try to make it clear for you. Some theory got more than 30 pages. This one, for example, at least more than 15 pages to complete the proof. Okay? It's not easy, learners. Okay? More, we should be very concentrated of researchers. In fact, me, Mourad Sultan Ezouidi, his own methods and researches, and I am here now, learns, show everything for you. Okay? To continue studying and to believe in yourself. Target, if you have something very important and you will hide it, there is no benefit, okay. But if you are going to share your knowledge, your science, because I believe that you are the science, the word science, okay, the science of the world or something like that, okay. And if you have a method, why not to share it and to let others solving the nth polynomial equation. There are some theory that is told it's impossible to do it, but we do this one, okay. Let's focus on what I'm telling you exactly. Yes, the nth equation, the nth linear equation. Okay, so it will be another time. I'm going to close this. Okay, go back, Mr. Mourad, to the, okay, to this one. Okay, We continue learning. We told that let's say I told I should calculate it, Mourad, please. You should calculate it. Okay. So we told I will erase this one. We told negative 6 times 11 square, negative 6 times 11 square is 1 to 1. Clear. Plus 16, plus 16 times 96 or 96 or 96 whatsoever. Okay, you can pronounce it as 96 or 96 or 96. Do whatsoever. Okay, the same important has to be equal to 810. This is the main important. Okay, yes. So whatsoever you pronounce this two-digit numbers, you should find 810. Okay. Now we continue. S2. S2 is 8 times 11 cubed. 8 times 11 cubed to the power 3 minus what? Minus 32 or 32. Okay, times 11 times 96 plus what learn is plus 64 times 361.625. This one learners has to be equal to 0. Okay, means we just construct this three the third degree equation to prove that the method of Cardan is false, and we obtain some examples where the method of Cardan can be applied. Okay, because the discriminant that he talked about is not a discriminant. Okay, it's the product of the three discriminant of two second degree equation. Okay, means if you are going to work with third degree equation, you have to find the discriminant of one second degree equation, and you should find the second discriminant of the second degree equation, and you should find the third second degree equation. Sorry, you should find for the second degree equation the third discriminant. When you multiply this, you will obtain a negative 4 s1 cubed negative 27s2 squared. Okay, this is my own formula. Okay, we close this parenthesis. Okay, now learners, I'm going to calculate now S2, S3. This is S3, Mr. Mourad. S2 we calculated. This is S3. Learners, don't be confused. S1 and S3 and S2 we obtain from my own discriminant formula that we did before. Okay, but now just I substitute the coefficient of my original fourth degree polynomial equation to this into this discriminant formula. Okay, now learners, I will calculate this. Okay, stuff. We told negative 3 times 11 cubed, negative 3 times 11 cubed. Okay. Sorry, not cubed, not cubed. Raised to the power 4. Ah, raised to the power 4. Oh, yes, yes, yes. You are very concentrated. Okay. So plus 16 times 11 squared times 96. I will tell you something like a joke, really. 4 years ago, maybe 2018, I was participated in a workshop in Muscat with some professors that came from England. Okay, and really I was astonished, or I was, let's say, uh, I was very delighted, sorry, or I was very happy because I met one professor who is very, very important for me. His own words and his the way of pronouncing words or speaking, something unbelievable. When I came back to the school, I started, let's say, speak like him. And let's say my headmaster told me, "What? You change your way of speaking, something very important. From where you learn this?" I told him from such a workshop. I was really, how to say it, influenced by someone who I loved him so much, and I wish that he's okay. Okay, thank you. And we continue. We told multiply by 96 minus 64 times 11 times 361.625. Okay, sure? Yes, sure. Sure? Yes, sure. Okay. This one is equal to negative 111,651. Okay, we use the unit circle here. Okay? Means means you are going to give all the value 0 except the last one. Okay? So, here learners, I obtain now, let's say, two sk minus 1, which are different to 0. We have S1 different to 0 and S3 different to 0. So you means that you are looking like you are working with the second degree from the equation, but after posing or putting u equal x squared or x equal u squared whatsoever. Okay. Now learners, according to me, we have p of x equal x cubed plus s1 of the x squared plus s3 equals 0. I'm going to introduce my discriminant formula for the second degree equation. S1 of the this is dash, of course, dash, equal S1 of the r square minus 4, okay, equal, this is equal minus, this is minus, okay, and this is plus 4. The opposite sign for the discriminant formula that you already know, okay, because this obtained from the discriminant formula of me. You see this one? Where exactly? Because we apply this learners. I will give it to you now. What is it? 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 What is it, Mr. Mourad? Where? Not this. Not this. Comes here. Up. This one, learners. You see? This one. I will take it with me. I need this. Okay, this is S1. Copy and okay. I will close it. No need now this one. Look here, learners, we told that. Why exactly like that? Because this is the discriminant formula when putting k equal 2, okay? I will write here if it is possible. Okay, comes here, equal. Like that. I will write here, learners, S1. Yes, I will make. Okay, this is, how can I change this? Okay, no problem. Okay, means negative, because this is comes like L0 for dq. The S1 for the R comes L0 for dq. Well, S3 comes L1. Okay, so it will be negative combination 1 choose 1, combination n choose 2. Okay, the n is now 2 because you are going to work with a second degree equation when putting or posing u equal x squared. Clear? So it will be S1 for the R equal negative. You see this negative? S1 squared. 2 choose 2 is 1. So that's why it's negative S1 of all the R squared plus 4 because n is 2 now. I'm working with the second degree. 2 squared, 4 times L1. The L1 is S3. Okay. So after finding this, you will find the value of S1 of all the R is minus 1052 squared. Means S1 of all the R is in fact the opposite, learners. If you would like to continue like that, is the opposite of the discriminant formula that you already know about it. Okay, but the discriminant formula is obtained from the is the first coefficient when putting k equal 2 in the discriminant formula of Mourad Sultan Ezouidi. And let's say we continue. We told that it will be negative 1052 squared. Means S1 of the R equal negative. Therefore, minus S1 of the R equal positive. Okay, so I will continue. It's very important. This one, I will close this one, learners, so that you can see the whole page. Okay, so learners, therefore, negative S1 of the R dash, Mr. Mourad, don't forget. Okay, equal S1 of the R squared minus 4 times S3. This is the discriminant formula I already worked with. But in fact, you should write it as negative, okay, which is positive 1052 squared. Now, learners, this is x square equal negative S1 of the R plus root of negative S1 R dash divided by 2. Just replacement. Negative S1 is 810. plus root of this divided by 2. Therefore, I will write it negative 1010 divided plus 1052 divided by 2 will give you 121. Which is that, learners? Did you remember? Did you remember this? Comes. This one, did you remember this? From where we got 121? Okay. From when you extend your polynomial equation. Okay, thank you. Now we continue, learners. We told that minus x square equal 121. So we can write in terms of unit circle. It will be xk, x subscript k belongs to 0 and 1 is 11 exponential ki pi. Means the first x root is 11, the second is minus 11. Means when look, listen, learners. When you tell minus 11 and 11, means this polynomial that you extended, what is the root that is clear for you? X equals 0, isn't it? So that's why 11 minus 11 equals 0. Okay, clear? Because alpha height will be L0, which is 11, minus 11 gave us 0, means x equals 0, in fact, is 0 for this 4-degree equation, 4-degree polynomial equation. We continue, learners. Okay. Therefore, we told this is the first two x roots of the 4th-degree polynomial equation. Okay. Now we should find the second the other two x roots of the 4th-degree polynomial equation. What we'll do exactly comes here, Mr. Mourad, if it is possible. We told here, see this one? Minus S1 of order R plus root of minus S1 of order R dash divided by 2. Now the second root is here minus, because this is positive. If it is in minus, make it positive. So it will be negative S1 of order R minus root of minus S1 of order R dash AK divided by 2. This is minus, Mr. Mourad. Okay, thank you. So it will be minus 810 minus k root of 10,052. It will be written as that. Minus 810 minus 10,052 divided by 2 equal negative 931. Okay? Therefore, xk, x subscript k from 0 to 1 is root of 931 exponential ki pi over 2, which is equal, in fact, plus negative root of 931 I. That's why here, learners, it comes 931. Okay? You see here? I told you, please ask me after. Okay? Therefore, you obtained the exact x roots and the exact roots. Okay? Now this is the third example. Okay? We obtain. Okay. I'll just take some rest, then I will continue. Okay? I'll just I will take some rest. Okay, learners. I will end this. I will close this. So, learners, waiting for you to tell me exactly, Mourad. Please give us, let's say, the Cantary example for cardinal method. Okay. If you are interested to know exactly where the method, I will tell you where exactly, which kind of examples that will work with the method of cardinal and that will never work. If a theorem or a theory does work with few n-degree polynomial equation and doesn't work for other polynomial equation, means you cannot tell this is a method. And the method of cardinal work with some and other with some other can't work. Okay? But for me, the discriminant formula for me it's very important because for any polynomial to the power n, you should know how can you find sk minus 1 of order r. And sk of minus 1 of order r can be found only by the discriminant formula of Mourad Sultan Ezouidi, okay, that had been generalized more than for any nth degree polynomial equation and for any nth linear equation. Okay. Okay, so 10 minutes, then I'm going to take some coffee and to pray first. Yes, and then now I'm going to pray, then I will come back. Okay, thank you for listening.